So I've had a couple questions about the flying distance example in section 1.10, so I decided to make a video. For this example, we have a ship that leaves port and sails on a bearing of north 47 degrees east for 3.5 hours. It then turns and sails on a bearing of south 43 degrees east for 4 hours. If the ship's rate is 22 knots, nautical miles per hour, find the distance the ship is from port. So what we need to do for this is draw and label a sketch. So we're going to start with port, which is let's make this port. And we want to represent north 47 degrees east. So what I like to do when I do that is draw a little set of axes here. And we know, let me write it up here, we have north, east, south, west. So we're going to go north, so up, and then 47 degrees in an easterly direction. So we're going to have something that looks approximately like this. So we know that this is 47 degrees. So let's say we are now here. I like to then draw another set of axes. And now I'm going to turn and sail on a bearing of south 43 degrees east. So in this one, I'm going to go south first in this direction. And I'm going to go 43 degrees east. And it's going to look something like this. So this in here is 43, and here we are here. And we want to know this distance. Okay, so let's call this we'll call this other piece B, and we'll call this C. And so we're looking for the distance from A to B. So what you should know is that we have these north-south lines here, and they are parallel. And we know from previous geometry that alternate interior angles are congruent. This angle here has to be the same as this angle here, so this is 47 degrees. So now we have a 90-degree angle in here because 47 and 43 are added together are 90. So we now have a right triangle. We're looking for this distance here. And now we need to use the other information here. We're going 22 knots for 3.5 hours. So 22 times 3.5. And also 22 times 4. So we get 77 and also 88. So again, when we leave port and sail to sea, it's 3.5 hours. So this length is 77. And then the other length here is 88. Now, because I actually have two different sides, I could just use the Pythagorean theorem in this case. Because x is my hypotenuse, I would say 77 squared plus 88 squared equals x squared. So we would have the square root of 77 squared plus 88 squared is x, and using your calculator you get 116.93. So to the nearest nautical mile, 117 nautical miles. Here's an example that has a little bit different information. Radio direction finders are set up at 2 points A and B, which are 250 miles apart, on an east-west line. From A, it's found that the bearing of a signal from the transmitter is north 36 degrees 20 minutes east, and from B, the bearing of the same signal is north 53 degrees 40 minutes west. Find the distance of the transmitter from B. So just as before, we really need a good picture to understand what's going on. So I'm putting my A and my B 250 miles apart, and I'm going to draw my little axes on both of these. So from A, it's found that the bearing is north 36 degrees 20 minutes east. So that means this angle here is 36 degrees 20 minutes. So I've gone north and then I've traveled in an easterly direction. Similarly, from B, it's north 54 degrees. So this here is the 54 or 53, 40 minutes west. So if I use a little bit of arithmetic here, we can see that this angle in here is actually going to be 53 degrees 40 minutes, and this degree in here is going to be 36 degrees 20 minutes, and that's just because these have to be 90. So if you were going to subtract, you would probably, instead of saying 90 degrees, 89 degrees and 60 minutes, and then subtract your 53 degrees 40 minutes. So we get 20 minutes, 9 minus 3 giving us 6, and 8 minus 5 giving us the 3. So that's how we would find those. So what you notice now is that since the sum of the angles of the triangle have to add to 180, this angle here is 90 degrees. So in this particular case, I don't have two sides. I only have one side, and I have some angles. And I'm looking for the distance from transmitter B, which is this blue, the length of this blue line here, x. So I have all of the angles in here, so I could really use any trig function that I wanted. I'm going to go ahead and use sine. So I can say sine of 53 degrees 40 minutes, so I'm looking at this angle here, is opposite, which is x, over my hypotenuse, which is 250. So now I'm going to do 250 times sine of 53 degrees 40 minutes is equal to x. Now, just a quick side note, when you do this in your calculator, it's almost easier, make sure you're in degree mode, to type 250 sine, and of course you know it's going to give you that parenthesis, rather than using the degree symbol and the minute symbol by using the menus. You can just say 53 plus 40/60ths of a degree. And that is going to give us 201.39, or to the nearest mile, 201 miles. I hope that helps with section 1.10. Let me know if you have more questions.